Okay, section 5.5 is sinusoidal regression. And what we're going to be doing is sinusoidal regression. We're going to be taking a set of data points and finding an equation that will fit these data points. So if we look, kind of get a quick sketch, we would get a sketch that's going to look something like this. And then we're back down and down here. So unless I missed one, we're getting, those are what a rough sketch of our points are going to look like. And if we kind of can make the assumption, well, if this is month 12 down here, month 13 would be January of the next year, and the pattern would kind of continue. Okay? And this pattern looks like something that can be modeled with a sine curve or a cosine curve, which is what we're going to start doing today. Okay, we're going to try and come up with an equation that will model these points. Okay, so first off, let's limit ourselves here. Let's try and find a sine function. Okay, we can do a cosine function the exact same way. Let's just try and use a sine function for this example. And then if you want, you could try one using a cosine function. It doesn't matter if you use a sine function or a cosine. You may have a different shift. You may have a positive or negative amplitude depending on how you're doing that. No matter what, you should get the exact same function. You should get the exact same graph. You should get the exact same answers if you're asked questions about it, okay? So if you use sine or cosine, it won't matter. So looking at this, we know our function is going to look like well, this is a temperature in terms of months, so we could put temperature in terms of months, but the actual formula for our equation is going to look the exact same. A times sine K, let's go T minus D plus C. So we got to work through and figure out from our table of values what our A is, what the K, what our shift, and if there's any vertical up or down shifts as well. So we're going to look through here, and we can solve any one of these kind of in any order we want. Let's look at solving the A value first. A value is our amplitude. And, excuse me, how we solve this is we go through and let's find our maximum value. So where's our max point? We're going to be looking at this set. And our minimum, okay? Because an amplitude is going to talk about how far our graph is, or the distance between our minimum value and our maximum value. Well, if we're making a sine function, we need it to be able to reach our lowest point and reach our highest point. So what we can do from that is we're going to take our maximum value of 22.8, subtract our minimum value of -14, and then we're going to divide them by 2. So our A value is 22.4 minus -15, and we're going to divide that by 2. $18.2. Okay, so we solve for A. Next look, and let's solve for K. K is going to be involved in determining the period. We know that the period is 2 pi over K. For this situation, given that our graph is months and temperature, what is the period for this graph? 12. It takes 12 months in one full year, 12 months to do one cycle. So in this situation, our period is 12. So we're going to get 12 equals 2 pi over k. We can rearrange for k. K is 2 pi over 12. K is pi over 6. Just all we're doing there is doing a quick reduction. So now we have an equation that's looking like 18.2 sine pi by 6 m minus d plus c. We have two things left to solve. We need to solve for the phase shift, and we need to solve for the vertical shift. Probably easiest to solve for our vertical shift first. So we can look at that. How do we solve for our vertical shift? Okay, so if we're looking, there's two ways to do it. So we could take our max point, which is 22.4. So to find our vertical shift, we take our max point and we minus our amplitude. So we have a max point of 22.4. We're going to subtract our amplitude of 18.2. And we are going to get a shift up of 4.2. So now we get so all that's left is to determine the phase shift. And to look at a phase shift, let's look at a regular sine curve. Because we're using a sine curve here. So if we took a regular sine curve and we look at our same period, so if we look at a sine curve with period pi by 6 x, we know that it's going to have do one complete cycle in 12, which means halfway it's at 6. And so our max points are at 3 and 9. So all we're doing is taking a sine curve that has a period of 12 and looking at where our zeros are going to be and our max and min points are going to be. Now, for this curve, it has a max at 3. It has a max at when x is 3. So that we take this, we know that for a sine curve of sine pi over 6x, we're going to have a max when x is 3. If we go up to our example has a max when x is 7. So what we need to do is we need to take our curve and shift it 4 units to the right. Because right now we have a max of a max at 3. We need to get our max when it's at 7. So we need to shift our graph 4 units to the right. And so a shift of 4 to the right is going to look like x minus 4. And because we're dealing with months, we can say our graph is going to be x minus 4. So we can go through and we can pull this together to get the end of our final equation for this. So we can model this table of values using the equation temperature in terms of months, 18.2 sine pi by 6 m minus 4 plus 4.2.